So here I'll rewrite these constraints because x is an integer, so I'll rewrite this as greater than or equal to 3 and less than or equal to 9, because the x and y are positive integers. Same thing with y. I'll rewrite this as less than or equal to 2 and then greater than or equal to 15, which means x plus y, if we add these inequalities, is between 31 inclusive and then 18. Now this condition n is greater than 25 is equivalent to n is greater than or equal to 26. Now this is really just n. So our simplification is n can take on any values between 26 and 31 inclusive. So the possible values are 29, 30, 31. It's just these 6. So the answer is 6. Now some students might just list out the values. I mean, that's also fine. You can just say, I mean, it will take a little bit of time, 4, 5, 6, 7, 8, 9. And there aren't that many. So y is 15, 16, 17, 18, 19, 20, 21, 22. So you're not just counting the pairs because, for example, if you get 3 and 16, which is 19, well, actually, let me use a different example. 3 and 19 is 22. Then we also get 6 and 16. That also gives you 22. So these are the outcomes we're looking for, distinct values. So you could say 3 and 15 is 18. 3 and 16 is 19. But these values do not satisfy this condition. So we just go to the first one. 3 with 22 also doesn't work. So you move on to 4, and you say 4 and 22. That gives me the first distinct values. And then you do the same thing with 5, and then you say 22, 5 and 22. That gives me 27, and so on and so forth. So you could take that route. 6 and 22. That's 28. 6 and 21 is already counted. 7 and 22 gives you 29, and 7 and 21 will just give you 28. And then 8 and 20 gives you 30. 8 and 21, we don't have to worry about it because that's 29, it's already here. And then 9 and 22 gives you 31. So you can take that approach as well. Sometimes I think it's less stressful. You don't have to be thinking in more general terms, which obviously is harder under pressure. So that approach would also work. So the answer is 6.